Alright, hi everyone, welcome to yet another interesting video. In this one, we are going to talk about a problem which is on LeetCode. It is valid parentheses problem and it is marked as easy complexity problem. It is an interesting one. So the description of the problem says, given a string S containing just the characters, the brackets opening and closing, different types of them, determine if the input string is valid. And we have to worry about only these type of brackets. um, yeah, and an input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order. Let's look at the examples. So here the bracket seems all right. We have the opening bracket and then we have the corresponding closing bracket, so the output is true. In this case also, the example number 2, bracket seems all right. We have opening and then the corresponding closing, so the response is true. False for this one because we have a different type of opening one and then we have a different type of closing one, so that's why the answer is false. Constraints, s is only parentheses, so there isn't any other character in the string that you're going to get, and the s dot length is not going to go above this one. So how to solve this problem? So the intuition that I have for the solution and the solution time complexity that I will be demonstrating is O of n, and the intuition is that to explain the intuition, let's go with this example. So this string is true, which means that it is a valid string from parentheses perspective. So I'm going to use hash map to store key values, like key would be this and the value would be this, and so on and so forth. So we'll have the closing bracket of that type would be the key and the opening bracket would be the value. So that's my hash map, and then we will do a for loop from 0 to s dot length, going through all the way to the strings, and we will look at each character one by one. And within for loop, what we want to do is that we want to check if hash map contains the corresponding character, which means that if supposedly we are at this character, whether that is existing in the hash map or not. Now within this, what are we going to do? So if there is a key for that particular character in hash map, that means that we found the closing bracket of all these three types. Now we want to check whether that closing bracket, the value of that closing bracket in the hash map, matches to the previous character in the string. And to store the characters as we receive in the string, what we are going to do is that we will have a stack. So create a stack of character type, and supposedly, let me also write, if the hash map does not contain the character, then that means that we gotta push the character. Okay, so for our example, which is this one, so when we are at this character, we will come and see, oh, hash map does not contain, so we're going to push the character into the stack. And then in the next iteration, we are at this character and hash map has a key for that. So hash map has a key. Now what we want to check is whether the hash map value for that key matches to the top of stack. And if it is not matching, then that means that our string is not valid. So that's what we are doing. And so we will have a flag that says that we will assign it as true, and if the condition, if hash map value is not equal to the stack.peak, then that means our string is invalid from parentheses perspective. And so I think the intuition is clear. So we, in this stack, we had this value, and when we were at this particular character, we checked hash map contains that character or not it contains, and then we're going to check whether the value is equal to the top of stack. In this case it is, so it will not go into this particular statement, so flag will remain true, and then in the end we will just return the flag. Now there is one edge condition, and let me explain that with this example. So the only input was the closing bracket. So while iterating, we found that yeah, there is the hash map contains the corresponding character, and it will try and go and check the peak. Now clearly this would result into an error because there isn't anything in the stack, so stacked out peak will result in an exception. So you got to check here if stack is not empty. And when that is the case, we will not do this, we will not go here, we will go here, and we will, push the character into the stack. So, and then we will, just come out of the loop because there is only one character. So in this type of edge condition where stack is not empty, you're going to return false, because that means there is some invalidness in the string. Alright, so with the intuition all being clear now, we're gonna write the code. So we got to have hash map character obj map new hash map and then we're going to do obj map dot put, and let me just copy paste some of the code to speed up. So we are so this is what we're doing, as explained in while we were talking about the intuition. We have a map which all of these things are added, stack is also created, we have one variable for the loop, and now we are going to do the loop to s dot length I plus plus, and then we are going to just write whatever conditions we discussed earlier. So what we are doing, we are looking at obj map dot contains key, and the contains key check is on char at I, and the other condition is that we do not want our stack to be empty. Obj stack dot size gotta be greater than 0. So that's our condition. If this condition is not met, we are going to push the character into stack, push the character char at I. Alrighty, and within this we want to have another condition which looks at obj map dot get s dot char at I is not equal to obj stack dot peak, and that means it's time for us to set the flag as false. Now one other thing that we have to do is that if this condition is met, like we found a match where the the closing bracket was the right one, we have to pop the element as well. Okay, so we are here now outside of our loops, and here what we're going to do, we want to check if the size is greater than 0, then that means that there is some bracket left and which didn't have a match, and that means the string is not valid. If the stack is size is 0, we want to check if flag is equal to yeah, oops, if flag is equal to, oh, I think we don't have to check it, you can just return flag. So I think that should be all. Let's just run it. Oops, cannot find symbol. Okay, okay, so that works fine. So during intuition, we did not talk about that why we need to pop. So why we need to pop is that then we do not want to check for a pair that has already been checked. Like in this case, when we were at this character, it will get pushed into the stack. When we are at this character, we will check, and the condition is not met. We are not going to set the flag as false. But at the same time, we have to pop, because then we do not want this closing bracket to be checked against this. We do not want that, because this pair has already been checked out, and there was no issue with this pair, so the previous opening bracket has to be popped for this program to work. Let's just submit it now. So this works fine. No issues, got submitted successfully. From time complexity perspective, it is O of n, as we discussed in the beginning. There isn't additional space. This stack, stack is there, so we can say that the space complexity is on. There isn't any space complexity because of this hash map, because it is constant. We will only have 3 elements in it. Alright, thanks for watching. Let me know if you have any questions.